Hello, everyone. Welcome. Welcome to this live online mathematics tutoring session from Namaste Online Tutoring. I'm Narayan Neupane. Um, so we come with these live sessions frequently, and if you want to look at the previous sessions or want to look at or watch some of the previously recorded math videos and want to learn more, don't forget to subscribe to this YouTube channel. So today what we are doing is we are going to work on some of the example problems on inverse of a function. Okay, so we'll be looking at 4 examples on how we can solve some of the inverse function problem. We are not looking at the theory or anything like that. We are just looking at the examples, and we are going to learn how to solve those problems. So begin with here we have the first example. If for a particular one-to-one function f of 2 equal to 4, f of 3 equal to 5, and f of 5 equal to 12, what are the corresponding input and output values of the inverse function? So here we are talking about a function. Okay, here we are talking about a function. So let me try to represent that function using a diagram here. And I'm going to call it a balloon diagram, or you can also call this as a mapping diagram. So let me quickly try to sketch that diagram here. Maybe something like this. Okay, suppose there is a function f. Okay, there is a function f from set A to set B such that the element 2 is mapped with 4. Or if the input is 2, the output is 4. So if we have 2 here, then this one maps to 4. So here you can see in set A we have 2, and the corresponding value on set B will be 4. Similarly, f of 3 is 5. That means if the input is 3, okay, the output is 5. The output is 5. Similarly, one more, f of 5 is 12. So if the input is 5, then the output here is 12. So that's a 12. And you can see that this function is a one-to-one function clearly. That is, each element of set A is uniquely matched with a single element of set B. Now we are asked to write what are the corresponding input and output values for inverse function. So we are now talking about the inverse function. That is the function from set B to set A. If it is a one-to-one function, there exists a function from set B to set A, and that's called the inverse function, denoted like that, f inverse. So here we want the input and the output of the inverse function. So for the inverse function, the input will be, let me write here, input of f inverse is, so for the regular function f, these are the input values, these are the output values. But for the inverse, the second set will be the input. Okay, the second set will be the input. Input will be 4, 5, 12. So input will be 4, 5, and 12. And the output will be these values from set A. Okay, output will be output of f inverse will be 2, 3, and 5. So basically what happened is in the inverse function, the input and output changes. For the function A, these are input. But for the function f, these are input. But for the inverse, these are output. Okay, so one very important thing for us to note here is when you talk about inverse function, we can find the inverse of a function if it is one-to-one function. And in the function and the inverse, the domain and range are interchanged. Okay, so that's why input are these values for the inverse, and these values are output for the inverse. Remember, if the function is f, the inverse is denoted by f inverse, like this. Okay, that's first example. Let's move on to second example. Here is our second example. Given that f of x equal to 1 over x plus 2 and g of x equal to 1 over x minus 2, are these functions inverse of each other? Remember, if two functions are inverse of each other, you can even take this as important note. Let me write here. If f and g are inverse of each other, then their composition, when I say composition, it's like FOG of x and GOF of x, they will be equal. Their composition will be equal, and each of these values will be equal to x. So their composition will be an identity function. So here, basically what we're trying to do is we want to find the composition of f and g, f with g and g with f, and see whether both of them are identity function or not. So let's begin. So let's see now, what we want is, let's find f o g of x. F o g of x is f of g of x. G of x is the inside function, and g of x is here. It is 1 over x minus 2. Now, what you have to do is, we have to plug in this value, 1 over x minus 2, into the function f where there is x. So it will be 1 over, now in place of x, we are plugging in this value because this is the input. So 1 over x minus 2, 1 over x minus 2 for this one, and we have a plus 2 there. So basically what we are getting is 1 over, in the denominator, 2 and 2 cancel, we get 1 over x. 1 over x is same as the reciprocal of 1 over x. Reciprocal of 1 over x is a x. So say the first condition, FOG of x equal to x, that condition is true here. Now we also need to check the second condition here. So let's do that. Also, if I want to find GOF of x, this is G of f of x. F of x is the inside function. F of x is this one, 1 over x plus 2, 1 over x plus 2. Okay, so I keep that z as it is. F of x is 1 over x plus 2. Now what you have to do is, this is g of 1 over x plus 2, but g of x is the reciprocal of x minus 2. In place of x, we have this one, so the reciprocal of that, 1 over x is the reciprocal. So the reciprocal of this will be x plus 2, and then minus 2. Again, you can see 2 and 2 cancel, we get x. So what we see here is, let me write that. Since FOG of x is equal to GOF of x, and both are equal to x, meaning of that is, this implies f and g are inverse of each other. So this implies f and g are inverse of each other. They are inverse of each other. So this is how we can prove whether two functions are inverse or not. Okay, because the idea is these two functions, if they are inverse, they will be one-to-one function. So that's why they show their composition as an identity function. So they go from, the original input to the output, and the inverse will reverse that. That's why we get that identity here. So always remember, if f and g are the inverse of each other, okay, if f and g are inverse of each other, then their composition is an identity function. That is very, very important note for you to remember. So if you remember those type of fundamental concept, then it is easy for us to do any math problem. So always remember, whenever you are doing any math problem, you need to understand that fundamental concept. Once you have that fundamental, it's easy to handle any type of problem. I hope you are getting it. Okay. If you have a question, feel free to send me your questions so that I can answer them in the chat, or if not, we can move forward. Okay, I'm going to pause here momentarily to see if you have any questions. Okay, look like there are no questions. So let's move on to next example. So here is the third example. We are asked to find the inverse of the function f of x equal to 3x minus 7. So you can see they have given this function f of x equal to 3x minus 7. Basically, this is same as y equal to 3x minus 7. Okay, y equal to 3x minus 7. Now, what we need to do is, because we are asked to find the inverse function, okay, because we are asked to find the inverse function, we have to perform a special procedure in order to find the inverse. If you know that, please send your comment in the chat on how we can do this. Let's see. Okay, that's right. That's right. You are sending your comments here. Very good. So I see that you are telling me to interchange the domain and range and then solve for the new y value. That is exactly correct. That's how we are going to, solve this and find the inverse. Very true. So because y equal to 3x minus 7 is one-to-one function, if you remember, this is a straight line. And if you draw the horizontal line for this one, so what I mean by that is, let me quickly explain here. So let me try to draw a quick graph to represent the function. Okay, very small, quick graph for that function. Something like this. This is x-axis. This is y-axis. You can see the y-intercept is negative and the slope is positive. So y-intercept negative, slope positive. So your line will be something like that. Okay, your graph will be something like that. This is the graph. Now, if we try to draw a horizontal line anywhere on this graph, you'll see that this horizontal line will cross the graph in only one point. Meaning of that is this function is one-to-one function. Okay, meaning of that is this function f of x is one-to-one. F of x is one-to-one function. This test that I've done here, this is called the horizontal line test. If the horizontal line crosses the graph at only one point, then the function is one-to-one function. Okay, so this is one-to-one function. So that means it has the inverse. This implies f inverse exists. Okay, that means the f inverse exists. And as you said in the comment, in order to find the inverse, we have to interchange the domain and range. In this case, your domain are the x values and range are the y values. So we are going to interchange that. So let's write this down. Interchanging domain and range, we get, what we get is this one here, 3x minus 7 will be 3y minus 7. 3y minus 7, which will be equal to, here we have equal to y, but now we have to write equal to x. Okay. Okay, we did that. As you mentioned in the chat, we did that. Now tell me what we do next in order to find the inverse. Okay, type your comment in the chat, how we are going to proceed further. What we need to do after this. That's right. We need to solve for y. Very good. We need to solve for y, and that new y will be our inverse function. Now, in order to solve for y here, let's see, in order to solve for y, what you can do is you add 7 on both sides. So it will be 3y equal to x plus 7. And then to find the value of y, we divide throughout by 3 or divide on both sides by 3. So y equal to x plus 7 divided by 3. So this new value that we get here, that's your inverse function. So you can write this as f inverse x equal to x plus 7 over 3. So always remember, while finding the inverse, the first thing that you need to check is, you need to check whether the function is one-to-one function or not, because we can find the inverse of one-to-one function only. And once we know that it is a one-to-one function, we know that the inverse exists. And once you know that the inverse of the function exists, in order to find the inverse, you have to interchange the domain and range. That you have to interchange the x and y value and then solve for new y. And that new y value that you obtain, that is the inverse function. Okay, you can quickly verify this if you want. If you take the composition of this function with the original function, that is f of inverse or f inverse of, it will be an identity function. You'll get x as the result if you try to find that composition. That's one way of checking whether the functions are inverse of each other or not, like in example 2. Okay, so this is how we can find the inverse of the function. Okay, type in the chat, is this example clear to everyone in the class? Wonderful, that's good. If you want to ask question, if you have anything, you can unmute yourself and ask, or you can also send the question in the chat. Are there any questions? Okay, one question here in the chat is, do we always need to check whether the function is one-to-one function or not? Yes. If the question mentioned that find the inverse of this one-to-one function, you don't have to check it. But if you have just a function like this and nothing is said about the function, make sure you verify that it's one-to-one function, because we can find the inverse of one-to-one function only. Okay, so that's very important. First, you need to check whether it's one-to-one function or not. Once you know that it's one-to-one function, then only you can find the inverse. Does that make sense? Oh, okay, got it, got it. Okay, you're welcome. Thank you. Great, we have one more example. Okay, let's move on to the last example. Here we go. A function g of x is given here. This function is y equal to g of x. If we want to write it, you can also label it like this, y equal to g of x, or they have already shown here along the x-axis we have x, and the y values will be g of x. That's why, that's how they have shown here. Now, what we are asked to do is, by looking at this function, we have to find these values, g of 3, g inverse 3, and g inverse 1. Okay, the first thing is we want to find g of 3. That means this is a regular function, right? This is a regular function. So the domain, this input is the x value here. So when the input is the x value 3, okay, if the input is that x value 3, then the output for this one will be, if you look here, the output will be 1. So g of 3 will be 1. G of 3 will be 1. In other words, g inverse 1 will be 3. This is same as g inverse 1 is a 3. That means for the inverse function, these will be the domain. So if 1 is the input, then the output will be 3. So that is also the answer to this third one here. G inverse 1 is a 3. Okay. And one more thing we have to find, G inverse 3. Also, G inverse 3, this is the inverse function. Okay. This is the inverse function. So the domain are along this vertical line or y-axis. So if you look for 3, here is your 3. Here is your 3. This is the input. So the output for this function will be 5. That will be equal to 5. Okay. So we got all those 3 answers if you look at it carefully. The first one is we are asked to find g of 3. So we got here g of 3 equal to 1. Okay. Next one, g inverse 3. G inverse 3 is 5. G inverse 3 is 5. And the next thing we want is G inverse 1, and G inverse 1 is 3, which is here. So this is how we should be able to read the graph of the function, which is a one-to-one function, and then we have to look for the inverse also. If you look at this function, you can see wherever you want to draw the horizontal line, you can see that the horizontal line will cross the graph in only one point. Meaning of that is this graph is one-to-one function, or you can find the inverse. And for the regular function g of x, these values are the domain or the input. But for the inverse of that function, g inverse x, these values along the vertical axis are the input or the domain. Okay. And again, the range for this function g of x are these values, whereas range for the inverse are these values along the x-axis. because for the function and the inverse, the domain and range interchange. Okay, that is the fundamental concept that you should know. If you have any question, you can ask me. How did it go? Just let me know in the comment because we are now done with this session. Yeah, wonderful. Thank you so much. Good to know that you got the fundamental concept. Okay. And any viewer watching this session live, thank you for participating, watching this video. And also, if you want to learn more math like this, don't forget to subscribe to this YouTube channel here. Okay, that's all for today. You guys have a wonderful day. Bye.